For me, my best my most best topic in OOP is of course the introduction, and this is the video.
So what is OOP? OOP, or Object-Oriented Programming, is a programming paradigm based on the concept of objects, which can contain data and code data in the form of fields, often known as attributes or properties. A code in the form of procedures, often known as methods. A features of object is that an object on procedures can access and often modify the data fields of itself. Objects have a notion of this of self in the OOP. Computer programming are designed by making them out of objects that interact with one another. OOP languages are diverse, but the most popular ones are class-based, meaning that objects are instances of classes which also determine their types. The importance of OOP. Programming provides improvement software development productivity over traditional procedure-based programming techniques.
Second, improve software maintainability.
For the reason mentioned above, object-oriented software is also easier to maintain since the design is modular. Part of the system can be updated in case of issues without a need to make large-scale changes. Third, faster development. Reuse enable faster development. Object-oriented programming language came with rich libraries of object and code developed during projects is also reused in future projects. Fourth, lower cost of development. The reuse of software also lower the cost of development. Typically, more effort is put into the object-oriented analysis and design, which lowers the overall cost of development. Last, higher quality software, faster development of software, and lower cost of development allows more time and resources to be used in the verification of the software. Although quality is dependent upon the experience of the teams, object-oriented programming tends to result in higher quality software. List of 5 object-oriented programming applications. First, abstraction. It is the process of picking out, abstracting similar characteristics of procedures and objects. Encapsulation. It is defined as wrapping the data under a single consolidated unit. In OOP, it is defined as binding data with a function that manipulates it. Polymorphism. It refers to a programming language ability to process objects uniquely according to their data types and or class. Interface. It comprises the language and the codes used by various applications to communicate with each other. Procedure. It is a part of a program performing a specific task. This is the example of feature that using OOP. And for the video, you can click the link below. Thank you!
And like in OOP, my favorite part also in discrete structure is the introduction.
Discrete structure. Discrete structure is a set of discrete elements on which certain operations are defined. Discrete implies non-continuous, and therefore discrete sets includes finite and countable sets, but not uncountable sets such as the real numbers. The terms discrete structures covers many of the concepts of modern algebra, including integers, arithmetic, monoids, semigroups, groups, graphs, lattices, semi-rings, rings, fields, and subsets. Application of discrete structures. Why discrete mathematics? Computers use discrete structures to represent and manipulate data. Computer science is not programming. Computer science is not software engineering. Computer science is no more about computer science is no more about computer than astronomy is about telescopes. Computer science is about problem solving. Why discrete mathematics? Because mathematics is at the heart of problem solving. Defining a problem requires mathematical rigor. Use and analysis of models, data structures, algorithm requires a solid foundation of mathematics. To justify why particular ways of solving a problem is correct or efficient, i.e. better than other way, requires analysis as well-defined mathematical model. Application 1. Discrete mathematics describe process that consists of a sequence of individual steps. This contrasts with calculus, which describe process that change in a continuous fashion. First, that ideas of calculus were fundamental to the science and technology of the Industrial Revolution. The idea of discrete mathematics underlie the science and technology of the computer age. Application number 2. The main theme of a first course in discrete mathematics are logic and proof, induction and recursion, discrete structures, combinatorics, and discrete probability algorithm and their analysis and application and modeling. Unit 1. Set and Proposition. This unit helps students develop the ability to think abstractly. This means learning to use logical valid forms, arguments, and avoid common logical errors. Set theory is the foundation of mathematics. Unit 2. Relations and Fictions. One-to-one, one-to-many, many-to-many. Unit 3. Groups and Rings. Problems in this field often arise or follow naturally form. A problem that is easily stated involving counting, divisibility, and some other basic arithmetic operation. While many of the problems are easily stated, techniques used to attack this problem are some of the most difficult and advanced in mathematics. Unit 4. Graph Theory. Everything is a graph. Labels, directed, etc. Graph theory can be used in modeling of social networks, communication networks, information networks, software design, transportation networks, and biological networks. Unit 5. Trees. Manipulate hierarchical data. Make information easy to search. Manipulate sorted list of data. As a workflow for composing digital image for visual effects. Router algorithm. And this is the graph applying discrete structure.
Most favorite topic also in computer system organization is the introduction.
Computer system organization. 1. The computer system is a combination of many parts such as a peripheral devices, secondary memory, CPU, etc. This can be explained more clearly using diagram. The salient points about the above figure displaying computer system organization is the OS device and CPU both execute correctly. In this organizational chart, show us what the involvement of memory to the other devices, such as memory to the graphic header to monitor, memory to device controller to keyboard to mouse to printer, memory to disk controller and hard disk. The computer system is a combination of many parts such as peripheral devices, secondary memory, CPU, etc. This can be explained more clearly using a diagram. The silent points about the above figure display computer system organization is the INO device and the CPU both execute concurrently. Some of the processes are scheduled for the CPU and at the same time some of are undergoing input-output operations. There are multiple devices controller, each in charge of a particular device such as keyboard, mouse, printer, etc. This is buffer available for each of the device. The input and output data can be stored in these buffers. The data is moved from the memory to the specific device's buffers by the CPU for INO operations, and then this data is moved back from the buffers to memory. The device controllers use an interrupt to inform the CPU that INO operation is complete. The importance of studying computer organization. Computer architecture and organization focuses on the function and design of various components necessary to process information digitally. The study of computer architecture and organization focuses on the interface between hardware and software and emphasizes the structure and behavior of the system. On computer users, we probably do not have to worry about this anymore. Then we need to know what our cars look like under the hood in order to drive them. We can certainly write high-level language programming without understanding how these programs execute. We can use various application packages without understanding how they really work. But what happens when the program we have written needs to be transferred and more efficient, or the application we can use does not do specifically what we want? As a computer scientist, we need a basic understanding of computer system itself in order to rectify these problems. Types of parallel processing: pipeline, array processor, multi-core. Types of computer use: single instruction, single data, single instruction, multiple data, multiple instruction data. Application inside the CPU: graphical cards, games console, supercomputers, model, multi-core chips. This is the fetch, decode, execute, reset cycle. This is the pipelining. Array or vector processing, control unit to the data. Multiple processor, pictures and video clips link. This the cycle: user, application, software to operating system to hardware, hardware to operating system to application to user. Computer hardware, operating system, system and application program.